Welcome back to the Automation Podcast, the world's number one industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience and thank you for tuning in this week. Now, for those of you new to the show, my name is Shawn Tierney of Insights in Automation, and each week I invite a new vendor to come on the show to tell us about their products and technologies. And during their presentation, I play the role as the audience and ask questions that I think you, the members of our audience, may have. And given that a quarter of our audience listens to the show, doesn't watch it, but listens to it, I'll also try to call attention to anything, any visuals or anything I see that the audio audience won't be able to see. So with that said, I want to welcome back to the show Noam from CaPow. We had a phenomenally great time last year. It was like May 3rd, podcast 152. Noam came on and he introduced us to CaPow, which is this amazing technology. And I know a lot of you may not have caught that episode. It was during the week of Automate. So maybe you were at the show, maybe you were busy. So, Noam, could you not only please reintroduce yourself to our audience in case they don't remember from last year, but also could you reintroduce your technology before telling us what's new and happening with your product?
Hi, Shawn. Thank you very much for having me again. It really was a pleasure last time, and it's even a bigger pleasure right now. My name is Noam Geffen, and I am the Chief Business Officer here at CaPow, which means basically I handle marketing, sales, business development in the organization. We are basically a company which is based out of Israel, a startup company, and the name is a word game for capacitive power. So CaPow is not only like a movement that you do like in comics books, but it's also capacitive power. And the reason for that is that this is the technology that we base our solutions on. Okay, as opposed to other wireless power delivery solutions that you are aware of that usually work with inductive, okay, or magnetic fields. Okay, we use capacitive power, which basically relies on electronic fields. The technology is different, and then based on that technology, we built a lot of knowledge, a lot of know-how, patent protected as well, which allows us to take this technology to push it to the end of the envelope. Our co-founders are all professors and doctors for electrical engineering, for power engineering, and we are a deep tech company, as I mentioned, founded in 2018 and based out of Israel. Maybe I can share with you a little bit about the motivation or what brings us to this specific field of expertise in this specific industry of automation. The ability to deliver power, okay, very efficiently is needed in several different industries, of course. You can think of consumer electronics, you can think of homeland security, you can think of aviation, okay? But in the world of automation, it is very, very, very crucial because the further we investigate, we learn that energy is the major root cause for automation inefficiencies. If you take an automation solution today, you find out that because of energy, you have charging downtime, okay? If the batteries are not enough to last you through the entire cycle of the shift, you need to charge, which costs you downtime, okay? Because of that, you have fleet inflation, so you need to compensate for that in additional robots, which cost you money from the get-go. Okay, technical faults, safety issues. Of course, we all know the transition to lithium was very, very good in terms of efficiency, but we pay for that in safety. Okay, lithium batteries basically overheat, sometimes explode. And all of these things basically are making an energy a bigger or a very big challenge to overcome. And we think, okay, what if we can, by a miraculous way, provide or deliver power constantly to the fleet while it's moving, so provide 100% uptime for 100% of the units, and do it in a way that the integration will be seamless to any kind of robot, okay, and also platform agnostic. So every kind of solution, AMRs, AGVs, ASRS solutions, overhead hoisting systems, even drones, which are used today for automation, for inventory. If we can, by a miraculous way, transfer power while they are moving, we basically solve this problem, or at least mitigated it by a lot. If I would try and look at, what power in motion, and that's basically the secret sauce of CaPow, to deliver the energy while the robots are moving, what benefits do power in motion has for current charging? It can be wireless charging, but it can also be regular connected charging. So first of all, if you can deliver power to robots while they're moving, you create 100% uptime. which is opposed to industry standard of sometimes 20 to 30% downtime of a robot. If a robot works for 5 hours but then charges for 1 hour, you lose money on that 1 hour. Basically, another thing is that if you need to charge today, you need to go to a designated area, okay, which is outside of the robot's original route. But if you can charge while the robot is doing its operational route, then basically you can also save on that. No to and from lanes, even to the point that you don't need to waste, let's say, additional warehouse real estate in order to put your charging stations, because today it costs money, of course. Fleet, as I said, is nominal versus extended fleets, which are today you need to pay for. And also there is the thing of the battery lifetime. Today, the profile for charging usually is you start working when the robot is around 80% full because you don't want to charge it to 100%. And then it gets degraded up to 40, 30, 20%. Okay, but this kind of charging regime on the battery exhausts it. What if you could find a soft spot for a lithium battery, which is around 70%, okay, and about half a C charging, and just trickle charge it. So every time let it go from 70 to 67, 70, 68. All the time keep it at that level. You can also extend your battery lifetime by up to 3 times. So all of that basically is achieved by delivering power to robots while they move. Maybe I want to, for our audio listeners, explain a little bit how it's done. And it's basically a very simple concept. Imagine that on the surface, okay, or in the facility, put on the floor or wherever you want a floor antenna, which whenever the robot goes on top of, okay, it gets boosted with power, like a Mario Kart game where they go on those mats and just gets a boost of power. On the bottom of the robot, we put an antenna, and on the surface, we put antenna. These antennas can be modular. The floor antenna can be short. It can be long, up to 30 feet. It can be wide or narrow or round or rectangle. Whatever the situation is, you can easily modify the antenna. And on the bottom of the robot as well, it can be on the bottom, on the side. You can even put it on the skis of drones, very easily modified. And whenever the robot goes on top of that, it gets boosted with power. Okay, I'm just sharing a video again for our audio listeners that it's also available now on our website that shows how it's working. The robot is traveling, okay, in its course, in route, does not deviate, goes on top of this floor antenna, and gets boosted with power. We provide 500 watts currently. It will be 1.5K by the end of the year. And basically, the idea is to give it a boost of power and put enough of those in the warehouse so the robot will have a 100% uptime. Diving a little bit into the technology and how it's done, this is basically where our core technology is. This is where we are very good at. The idea is pretty simple. Imagine the same concept as a radio station. Okay, and in the radio, when you turn the knob, okay, you try to lock in to the best possible frequency that will allow the best possible reception. We do the same thing, but with the energy concept. We are locking on to the best available energetic station, as we call it. And while the robot is moving and the characteristics change, okay, the distance between the robot and the floor changes, the speed changes, everything. So the capacitance between the robot antenna and the floor antenna changes. We know how to auto-tune into that and change it on the fly. That's the core ability of CaPow. And this is where our basic knowledge comes from. Let's maybe review a few other options in the market, okay? Or let's try and understand why we think this is the best possible solution for the automation world. So, starting with today's connected charging, everyone is using connected charging. It's there, okay? But it has all the drawbacks that we discussed. You need, as a robot, you need to leave your operational route, go to a specific station, wait there until you get charged, okay, and only then get back into circulation. The transition to wireless charging, but a static one, basically allows the solution to be safer because you don't have open connected connectors, but you still need to leave the operational area. You still need to wait, okay? And this world, the innovation there is basically more faster chargers, bigger batteries, stuff that will basically mitigate a little bit the charging downtime, but it will never solve the solution. okay, and then you exhaust the battery. You have other operational enhancements, for example, like battery swaps, okay, hot swaps, or you have opportunistic charging, but these things take a lot of money. Okay? You even have some dynamic wireless solutions, which follow like a magnetic coil, but for that you need a very, let's say, very heavy investment in the warehouse. You need excavation. Those things are huge today. This is more suitable for moving tractors and locomotives than using mobile robots. And the idea is that if you look at what this solution brings to me from an operational efficiency perspective, can it improve my operational efficiency, and can I apply it to all the platforms out there? Basically, there is a trade-off. So for connected charging, you can basically put it on every kind of vehicle, but it will not improve your operational efficiency. While having dynamic wireless charging as you have today will improve your operational efficiency, but it's not applicable for most of the market. The only solution, which basically the integration is very easy to do, and it applies to all robotic makes and models and even standards like AMRs and AGVs, etc., and brings full operational efficiency, 100% uptime, is CaPow's in-motion power delivery. There is a question that I usually get, so do I need to cover the entire facility with these floor antennas in order to deliver 100% uptime? And the answer is, of course, no. What we have is a software tool called Floor Planner, which our customers get. And for this tool, basically what you do is you upload your facility layout, how your facility looks like, which kind of robots would you like to deploy, and the algorithm calculates for you where are the strategic places you need to lay down those floor antennas, how long they should be, okay? And of course, what is the minimal coverage gained? We are getting to the point that we know with less than 2% coverage of the entire facility, we get 100% uptime easily. Okay, sometimes we can move 100 robots in a fulfillment center only by using 2 of those stickers, just because the algorithm knows exactly where to place them. Another thing which is a byproduct, which is very interesting to discuss, okay, is the strategy. Today lithium batteries are an expensive part of the robot. Robots that cost 35, 40, 45K dollars. The battery for them also costs 3, 4, sometimes 5K dollars. It's a lot of money, and those batteries are heavy, inefficient, and as I said, lithium batteries are a safety hazard. By moving the concept from deep charging, deep discharging to trickle charging, okay, and basically using only those kind of small boosts, you don't now need a big battery. Why deploy a 2K watt hour battery that will last you for 6 hours, where all you need is to travel for 2 minutes until you meet the next floor antenna? So basically what you can do is you can reduce the spec of the battery and make do with 10% or 20% of the original size and still get 100% uptime. This strategy is up to you, of course. CaPow will support the original battery, will support reduced spec, and in some cases, we can even eliminate the battery altogether, replace it with a small supercapacitor, and basically reach 100% uptime and the lithium-free concept. One of our customers actually put a green sticker that says lithium-free battery on it, which basically is a very nice thing to show around ESG-wise.
Well, I think too that a lot of companies are going to get lithium battery fatigue after a while, because as they go through their third or fourth change out, they're going to be like, there has to be a better way. And I love the fact that you have the ability to provide the supercapacitors, that you've tested some out, that you know which ones work well in these applications. I did want to ask you one thing, though, that's very clear to me on this screen, and you may be getting to this later in the presentation, but you not only put the antenna on the floor, the sticker or the mat on the floor, you have the antenna on the bottom. In this case, we're looking at a lot of AGVs, or AMRs, so we put a sticker on the bottom. That's the antenna on the bottom. And I know they can go on any side, but you also have a component that goes inside between the battery or the supercapacitor and your antenna. Can you explain what that is?
Yeah, this is a receiver. So basically, when the energy flows wirelessly from the floor antenna to the robot antenna, it is connected to a receiver which connects parallel to the battery and the rail of the robot. And the concept is that it absorbs the 100% power from the CaPow transmitter, and it basically decides how much will it pour to the rail of the robot to let it continue moving, and how much will it charge the battery. So if we take a fulfillment operation with robots, which usually consume around 100 watts on average, if we deliver 500 watts, it means I need 100 watts to let the robot continue moving, and the rest of the 400 will charge the battery at the same time while the robot is moving.
And I think that's important because you can't just put a battery across the line. You have to have a electronic battery charger circuit in there to charge the battery correctly. And it sounds like you guys have worked with a lot of different battery manufacturers to make sure that you're charging it to their specs to make sure it's safe and no harm comes to the battery. Is that correct?
Yes, exactly. And moreover, we know how to work with all kinds of let's say, energy forms. So it can be a lithium battery, a lead acid battery, supercapacitors, bus bars. This is the
Okay.
core knowledge that CaPow came from. Let me just review shortly a case study that we have done with a customer of us. Unfortunately, I still cannot reveal the name of the customers because the PR is about to be launched in a few weeks. But let's say it's a very large tier one operator from the manufacturing industry, and its problem basically was fleet inflation. So he has a fleet of 50 robots, 50 AMRs, and his problem is every AMR costs 40, 50K dollars. His problem is that those AMRs have a work to charge ratio of 4:1, which means if you want to have a cluster of 4 robots, you need to have 5 because the fourth one is always hogging the charger. So you need a spare one. And if you have a 50 robot operation divided into clusters, you need a lot. You need like 20 to 30% additional robots just for that. A bigger problem that it has basically is the operational efficiency. Okay, when you have additional robots that and you need to manage them, and some go to the charger in a different place, and sometimes you have traffic jam just because the fleet is inflated, you are not efficient. You lose a lot of money on that. And what we did is we deployed our solution in a cluster over there, and we showed them that first of all, we gained 100% uptime. Instead of 4:1, it's an infinity to one. Those robots, from the minute that they were deployed, they never stopped working. So they're working all the time. So what he could do is basically collect all the spare robots, which now he does not need to use. Okay, I neglected to say at the beginning, but this was a retrofit project. So we know how to work retrofit, and we know how to work with new models as well. This project was a retrofit, so we basically took all the robots, okay, that he saved just by working with CaPow, and rediverted them to other operational routes, and basically gained much more production from them. So immediately it got more productive. Another thing that he gained, okay, and this is also very interesting, is then this was, of course, from day one. After a few weeks, he did some measurements, and he found out that automation solution is basically responsible for 4% of the entire facility's operational losses. Okay, and 2% out of them are because of charging downtime. So immediately from deploying CaPow, he saved this 2%. So 50% of the entire operational losses caused by automation were immediately saved. But moreover, additional almost a percent was saved just because now queues became much more effective, okay, much more efficient, no queues, all the time working. This is a huge success for him. Just to show you here a few graphs, and again, for our audio listeners, I will just share that I'm showing a graph of the robot before CaPow. This is the regime of charging, and you can basically see, a robot getting charged and then discharged, and you see that within 180 minutes of working, so 3 hours of working, 40 minutes the robot spent on the charger, which means basically it's not working. Okay, if you try now with CaPow, basically what you see here on the graph is it's not a deep discharge between 80 and 30 or 80 and 40%. You always hover between 80 and 70 because that's the most efficient part for the robot. And okay, all of this is gained while the robot is doing its actual operational job. So you get 100% efficiency, the robot's energy never depletes, and you increase your operational efficiency. In summary, I will just say that the immediate proven benefit of Genesis, our power delivery system for in-motion robotics, is the dramatic cost of ownership. if you can save on charging downtime, you can save on the robots within the fleet. You can save on the cost and size of batteries. You can save on the operational expenses like the stations, the current charging stations that basically hogs up real estate in your warehouse, and you can use them for other stuff. All of these amount to a number that we calculate with our customers to be 35% dramatic decrease in the cost of ownership that costs you to deploy an automation solutions. Other benefits, of course, is you can now control your roadmap. Our solution can be tailored, as I said, retrofit or new design to every kind of make and model. So even if you have a forklift next to an AGV, next to an AMR in the warehouse, they will all get powered by the same system. Okay, you can change or reduce or even eliminate your lithium batteries as much as you would like, and you are basically the one that control your roadmap. Solution just got much more safe, right? So less lithium batteries. Everything is it's much more safe, and of course, efficiency goes through the roof. I will just end with a short video from Modex, the logistics show that we have exhibited in 3 weeks ago. And over here, what we actually demonstrated is a floor antenna. And what you can see here is you can see two robots from different makes and models. Right now, one is a mirror platform, and one is a Thouser, a Dube platform. Okay, which are completely independent. One uses lithium battery, the other uses lead acid battery, and you can see them going, okay, in movement on top of the floor antenna, and you see them getting charged while they go. Okay, by the way, we can support speeds of up to 5 meters per second, so pretty fast. Okay, and they are charging while they're going, and throughout the show, we didn't even charge them on that. So the technology is here, the opportunity is here. We address AMR manufacturers, distributors, and end customers, operators directly. And we would really, really love, Shawn, to talk about our technology and our solutions all day long.
Awesome. And before we get away from this video, what about, like, I know people are going to accidentally walk over these antennas, right? I mean, typically you would avoid something like that. So, the AMR, it can have all the time on it. But what kind of caution do you need for people who are walking around the facility? Do they have to avoid them? Do you need to put big yellow tape around it? Is it safe for a person to walk over it?
Yeah. So first of all, safety-wise, it's completely safe to walk over it while the robot is on there as well. The only part which is electrified, which is basically transfers energy, is the one underneath the robot. So even if you stand next to it, nothing will happen.
Okay.
This is one thing. Second thing, as I mentioned, this is in terms of deploying it. It's very easy. You can it's not mounted. You can pick it up and move it aside if you need. But it's very rigid, so you can go over it with a forklift as well. But coming back to the safety side, and we have the safety certifications to prove for that. Completely safe.
Now, I do know in some locations people wear some steel-toed construction-style boots. I would imagine you'd probably wouldn't want those on it. I mean, what are we talking about for wear and tear? I mean, you get your AMRs driving over this all day long.
Yeah. Yeah, we for measurements and tests that we have done, we can endure the weight of something like a 6.5-ton forklift going on top of that 500 times a day for
Wow.
4.5 years.
Wow.
So
That's
this
cool.
is this is meant for the automation industry. We are aware that it's not always like fulfillment centers with tiny robots. Sometimes it's manufacturing, and you have forklifts and you have tuggers, and you have lots of cranes and stuff like that. So this part should be very much endured, definitely. Yeah. By the way,
Excellent.
we have other mechanisms that
Hmm.
can identify when you have metal in field, when you have people stepping over it and whatever. It's safe, but we can still identify that and send alerts. I didn't
Oh.
share it. I didn't share it, but we have a software layer, okay,
Hmm.
which called GEMS, which is the Genesee Energy Management System.
Hmm.
This system is the software. Basically, first of all, aggregates all data from the robot, which is relevant. All data from the facility, the floor antennas, can be integrated with the WMS and sends a lot of notifications, do proactive maintenance, alert you when the robot is misaligned, because sometimes robots are driving, and I get this question a lot, what happens if the robot is missing it by 10 centimeters? So
Mhm.
first of all, with our system, misalignment is up to 50% of the size of the robot. So even if 50% of the robot is tilting to the side, you will still get more than 80% of the efficiency, the power. But we can also alert to the WMS, listen, that robot over there is missing the sticker by, missing the floor antenna by 10 centimeters, something is wrong with navigation. Or in that floor antenna on the other side, someone dropped a screwdriver. So the system will still work because, as I said, it's capacitive power, which
Mhm.
is not sensitive to metal in field, but I can still alert that to the operator.
That's awesome.
One more time before we go, I'll just all of these videos, by the way, are at our website, and we will gladly have remote demos and sessions and introduction centers to everyone who is basically interested in this kind of technology and this kind of a solution to increase the operational efficiency.
Yeah, I'm assuming that there's several people listening or watching who are like, yeah, we're going to need this. How do they get in touch with your company to learn more?
So we are on LinkedIn. We are on YouTube. We have a YouTube channel. We have our own website, which you can basically go in and basically play with some of the stuff that I've showed here. So the floor planner, the tool that lets you know how many floor antennas will you need, it's available free on our website. We have a calculator on the website that you can basically put your data and see immediately how much money CaPow can save right from the get-go. Other tools and stuff, come visit our website. It's really fun.
Excellent. All right, that's great. Was there anything else you wanted to cover today, Noam?
No, I just wanted to thank you very much for this opportunity, and just being a guest at your podcast really warms my heart. Last year was a fun. This year it's even more fun, and I really hope that you will have me next year as well, so we can show other improvements that we have done.
Well, no, I think this is great. I just think you have this is such a next gen product that I know, just the cost of having those extra robots charging, basically down, it's something that from an automation standpoint, that's not normal for us. We have stuff that runs 24/7, 365. So be able to extend that to our mobile devices and even can you talk? I don't think we talked about drones as much this time. Can you talk a little bit about drones? Because I think a lot of us automation folks, we know what drones are, we see them, but we don't usually see them in our warehouses. I know they're really taking off in warehouses. And could you talk a little bit about the hoist crane type of linear stickers as well? Because we didn't cover either of those, and I think those are two applications that I think some of our listeners will have, maybe more so than an AMR. So could you touch on that for a second?
Yes, sure. Well, let's tackle drones first. I mean, drones have two, let's say, major challenges within them. One, of course, is the hang time, okay, the fly time. Okay, they basically they don't have a lot of time in the air, and they constantly need to drop for charging. So one option is charge them while they are midair. Okay, of course, it might not be applicable for very heavy drones, but the ones that are used currently in the industry just for inventory are
Mhm.
lightweight. And a cool thing about the CaPow's technology, and you mentioned that while we address ASRS solutions or pallet shuttles and stuff like that, the same concept that for floor antennas can be used to put on rails and hoists and stuff like that. So I can play with it, and I can make a 30 feet long and 2-inch wide antenna and put it on inside the rail. So in the same concept, I can also put these kind of antennas on pods and stuff like that. And whenever the drones gets near that, because the distance between the antennas can be up to 10 centimeters, up to something like 4 inches, okay, 3.5 inches, then the drone can just hover next to it and get the energy. Okay, sometimes we also use that for forklifts. If you don't want the forklift to go on top of the antenna, we will just put the antenna on the side, and the forklift will just drive next to it. So this is one way to solve that. With the POC that we have done with the drone company, instead of landing every 35 minutes, it landed once in 3 months just for
Wow.
maintenance.
So instead
Um,
of having the stickers on the floor, the antennas on the floor, you can run them down the side of the shelves. And
exactly.
so it's traveling to where it needs to go. It can be charging just like an AMR, traveling across the sticker on the floor to get where it's going. And so
Exactly.
it can just stay up and run for like you said, 3 months. That's amazing.
Yeah. Yeah, it is. Another problem worth mentioning is what we call again misalignment. Okay, drones, in order to get charged, they need to land, and you either need to manually plug into power, or
Yeah.
today you have systems that need to centralize the drone while it's landing in order to do the connected charging. Wireless charging as today, if it's not CaPow's technology, but let's say traditional inductive technology, if you're not completely aligned, if you miss the
Hmm.
pod, and it's correct, the same thing as robots. If you miss the pod by an alignment of 2 centimeters, 3 centimeters, you will not get charged. With our spatial distance that we allow, it goes the same thing for a drone. Even if it lands crooked, it means the X and Y lands on the side, it can still get powered. And this is a very good advantage where you can just put a pod and not force the drone to land exactly at the same, but let's say in the vicinity of the pod. So with these two things, and we have basically an experience of years doing that, we are also very good at that. So as I said, the technology can be used and utilized in many, many different ways. But we think, the automation world is something that is starving for 100% uptime, a 24/7
Yeah.
solution. And we think, going the CaPow way and CaPowering your devices is basically the way to do that.
Yeah, I think we have all experienced inductive chargers on our new phones, and maybe you got a new car and you get the inductive charger built in, and it's like if you have the wrong case on, or you have, if you don't have it right on top of that charger, it does not charge. So this is such an just an advancement as far as being able to charge devices, especially devices that should be on the move 24/7 in most applications. But well, Noam, I really appreciate you coming on the show. I always enjoy talking with you and talking about your technology. Anybody in the audience, if you guys think this is something you could use, please reach out to them because they're just been a great company to work with, and it's exciting new technology, which is can't be said for every show we do, but I really enjoy looking at this next gen stuff. So, Noam, thank you again for coming on.
Thank you for having me.
Well, I hope you enjoyed that episode. I want to thank Noam for coming on the show and bringing us up to speed on CaPow and all the different applications they can solve. Now, with that said, if you did enjoy this episode, please give us a like, give us a sub, give us a share. That is the fuel that keeps this show on the air. And if you want to try out our new community, it's completely free. You can visit us at theautomationblog.com/community. Also, if you know anybody looking for PLC, HMI, or SCADA training, please tell them about my website, theautomationschool.com, where I teach on Control Logics, Compact Logics, PanelView Plus, Siemens S7 PLCs, and so much more. We even have a brand new Arduino course that is just $9.99. With all that said, I want to wish you an awesome week and encourage you to stay courageous and stay fearless. And until next time, my friends, peace.